First one is Newton's forward interpolation formula. See, this is the Newton's forward interpolation formula. In this formula, we have y naught delta y naught delta square y naught delta cube y naught and so on, which can be found from difference table, finite difference table, and r we have to find so this is the formula for Newton's backward interpolation formula. In this formula, the terms yn, nabla yn, nabla square yn, nabla cube yn, and so on can be found using finite backward difference table, and r, the value of r we have to find and substitute in these places while solving the problem. Now the question is when to use forward interpolation formula and when to use backward interpolation formula. If the value of x is near the beginning of the table, then we use forward interpolation formula, that is x is close to x naught. In this case we use a forward interpolation formula. If your x is close to xn, then we use a backward interpolation formula. That is, suppose this is your x naught and here is your xn, and this is the half here. If your x lies in this half, then we use forward interpolation formula. If your x lies in the second half, then we use backward interpolation formula. Step-by-step procedure for problems. In the first step, we construct the difference table in accordance with the interpolation formula. So that is, we need to construct the difference table first. In the second step, we compute the value of r. How we find the value of r? See, so this is the formula for r. In the case of forward interpolation formula, where x naught will be given in the data, and h is the step length, that is the gap between any two consecutive values of x. This is the formula for r in the case of backward interpolation formula. Where xn will be given in the given data and h is the step length, that is the difference between any two consecutive values of x. In step 3, we substitute the values of r along with the values of finite differences in the required interpolation formula to find the value of y at the desired value of x. Let us take one problem on interpolation. So in this problem they are asking us to find the value of y, at 1.4. Now the question is which formula we need to use. Since this 1.4 is very near to 1, that is very near in the beginning, that is it falls in first half. If this is the half, then the value of 1.4 is falling in the first half and near the beginning. So that's why we have to use the forward interpolation formula. Let us look at the solution. Here we have to find the value of y at the value of x, which is 1.4. So we need to find y at 1.4. Here, since the value 1.4 is in the first half, of the table, that is near to 1. So what we suggest, Newton's forward interpolation formula is appropriate. Newton's forward interpolation formula is appropriate, and we shall construct the forward difference table. As we all know, here we write the values of x, and in this column we write the values of y. Since we are using forward interpolation formula, we need to write delta y, delta square y, delta cube y, delta to the power 4y. If you are using Newton's backward interpolation, then you need to write nabla here, nabla square here, nabla cube, nabla to the power 4. Now let us see what are these entries are. So we all know how do we find these entries. 26 minus 10 is 16. 58 minus 26 is 32. Similarly, the other two entries we can find. And how do we get this 16? Is 32 minus 16 gives 16, and so on. So this 6, how we got this 6? 22 minus 16 will give you 6. Similarly, 28 minus 22 will give you 6. Then continue for the next column. 6 minus 6 is 0. Since this entry is only 1 and it is 0 also, we stop the column here. And this is the formula for Newton's forward interpolation. Newton's forward interpolation. In this formula, what all entries we have? First entry is y naught. Where is y naught? Y naught is here, that is 10. And next entry is here, delta y naught. Where is delta y naught in the table? See, this is your delta y naught. As you know, in the beginning we have already explained. So these entries are leading forward entries. Delta square y naught, delta y naught. This is delta y naught. This is delta square y naught, delta cube y naught, delta to the power 4 y naught. So we use all these delta values in the formula here, and we find the value of r in the next slides. So these are the requirements in the formula. Since we are using Newton's forward interpolation formula, this is the formula for r we need to use, and the value of x where we require y is 1.4 given in the question. X naught, beginning value of x, is 1 from the table. X naught is 1 from the table, and h, the width size between any two consecutive values of x, is 1. So therefore, if you use this formula here, what do you get? What is the value of x? The value of x is 1.4. What is the value of x naught? X naught is 1, and the value of h is 1. If you simplify, you will get the value as 0. From the table which we have constructed, the values of delta y naught, delta square y naught, delta cube y naught, and delta to the power 4 y naught are these, which can be seen easily from the difference table. When we substitute the values of these delta values and the value of r, that is 0.4, in the RHS of this formula, we get these things. That is in the place of yr, we have written y at 0.4, which is the requirement. In the place of y naught, what is the value of y naught? From the table, from the given data, it is clearly seen, it is 10. In the place of r, put 0.4. In the place of delta y naught, put 16. Similarly, when you come for the next term in the formula, this is r into r minus 1. So we have put here, that is the value r minus 1 divided by 2 factorial. What is 2 factorial? 2 into 1, which is just 2, into delta square y naught. Delta square y naught value is 16. So put delta square y naught value here. Next term is r into r minus 1 into r minus 2, which we have put here, r minus 1, r minus 2 divided by 3 factorial. 3 factorial is 6, into delta cube y naught. What is delta cube y naught? It is 6. So put 6 here, and we have not written the next term. Why? Because delta to the power 4 y naught is anyhow 0. So the next term will be 0. So we have neglected this term, last term. If you use your scientific calci and simplify this much, you get the answer as 14.864. So this is how we find the value of y at 1.4 using Newton's forward interpolation formula.